The Drake equation, estimating the count of alien civilizations. It's a cool, clear evening, and the vastness of the night sky stretches endlessly above. For millennia, humanity has gazed upward, pondering a question both humbling and thrilling. Are we alone in the universe? This profound question gained a structured framework for exploration in 1961 when Dr. Frank Drake, an astrophysicist at the National Radio Astronomy Observatory, devised an equation to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. This equation, now famously known as the Drake equation, became a cornerstone for the scientific search for extraterrestrial intelligence, SETI. But what does the equation tell us, and what does it mean for the possibility of alien civilizations? The equation. A cosmic tool, the Drake equation is expressed as n equals r times fp times ni times fel times phi times fc times l star, where .n equals the number of civilizations in the Milky Way galaxy with which humans could communicate. R asterisk equals the average rate of star formation per year in our galaxy. Fp equals the fraction of those stars that have planetary systems. Ne equals the average number of planets that could potentially support life per star with planets. Fel, the fraction of planets that could support life where life actually develops. Fi, the fraction of planets with life where intelligent life evolves. Fc, the fraction of civilizations that develop detectable communication technologies. L equals the length of time such civilizations release detectable signals. Each variable invites exploration, uncertainty, and debate, turning the equation into more of a thought experiment than a precise calculation. Yet it opens the door to scientific discussions about life beyond Earth, breaking down the variables. One star formation rate R. Our galaxy contains around 200 to 400 billion stars, and estimates suggest about 1 to 3 stars form each year. With newer data from telescopes like the Hubble Space Telescope and James Webb Space Telescope, we can confidently say star formation is a consistent process in the Milky Way. Fraction of stars with planets, FP. Thanks to discoveries by missions like Kepler and TESS, we now know that planets are common. Nearly every star hosts at least one planet, meaning FP is close to 1.03. Number of habitable planets, Ni. Among these planetary systems, how many planets are in the habitable zone, the region where liquid water can exist? On average, researchers estimate Ni might be around 0.4 to 0.5 per star with planets, based on current exoplanet surveys. Earth is our only data point, and life here began relatively early, suggesting it might not be rare. Optimists argue FL could be close to 1.0, while skeptics suggest environmental hurdles might make it lower 0.5. Planets with intelligent life, Fi. Intelligence is a game changer. While life might be common, intelligence might be exceedingly rare. After all, intelligent species capable of building civilizations took billions of years to evolve on Earth. Sixth civilizations developing communication, AFC. Not all intelligent species may develop technology capable of interstellar communication. Factors like societal choices, environmental challenges, or self-destruction could influence this fraction. Point 7. Longevity of civilizations, L. Finally, L reflects how long a civilization actively sends signals into space. If civilizations tend to destroy themselves through war, resource depletion, or environmental collapse, L might be tragically short. From speculation to discovery. When Drake first proposed the equation, most of its variables were educated guesses. But today, advances in astronomy and biology provide increasingly refined estimates. Still, the equation leads to wildly varying results. If L is only 100 years, a pessimistic view, N could be less than 1, suggesting we might indeed be alone. If L stretches to millions of years, N could be in the thousands, implying a galaxy teeming with life. SETI efforts, such as scanning radio waves for alien signals or searching for technosignatures, are attempts to find evidence for FC and L in real time. What if we found them? Imagine the world's reaction if tomorrow we detected a signal, a deliberate, undeniable communication from another civilization. It could change everything, from our understanding of science to the philosophies and religions guiding our lives. Questions would flood in. What should we say in return? Could contact be dangerous? What might we learn from their society, history, or technology? Some scientists, like Carl Sagan, urged caution, believing that announcing our presence too openly might attract unwanted attention. Others, like Stephen Hawking, warned that an advanced alien civilization might view us as insignificant, or worse, as a resource. Are we already seeing signs? While definitive proof remains elusive, unexplained phenomena like fast radio bursts, FRBs, or the mysterious interstellar object Oumuamua keep the question alive. Could these anomalies be natural, or do they hint at something more? The Fermi paradox. Where are they? The Drake equation brings us hope, but it also raises an unsettling question. If intelligent alien life is probable, why haven't we found any evidence yet? This is the crux of the Fermi paradox, named after physicist Enrico Fermi. Proposed solutions range from advanced civilizations self-destructing before contact, alien societies deliberately avoiding us, Earth being in a remote or undesirable part of the galaxy, a universe of possibilities. Whether we're the only intelligent species in the galaxy or one among countless others, the implications are staggering. If alone, we bear the immense responsibility of preserving and expanding consciousness in the universe. If not, we may one day find kindred spirits among the stars, transforming our view of existence forever. For now, the Drake equation remains both a scientific tool and a philosophical mirror, reflecting our deepest hopes and fears about the cosmos. Every star we study, every exoplanet we find, and every signal we listen to brings us closer to an answer. And as we gaze into the abyss of space, we're reminded that the ultimate question, are we alone, might one day lead us to humanity's most profound discovery.